All right, so the last time we met, we talked about arrays. I'm gonna go ahead and finish this topic today, but before I do that, we need to start talking about the midterm. So, yeah, it's ready. Yeah, it's gonna be after spring break. So, the topics, like normally I'll give the midterm before we start chapter 9, but we still have to finish arrays, and then I also have to show you how to read and write to a file. That's something else I'm going to test you on. Is the serializable class? We haven't talked about that one yet, but it's an interface that you also implement so that you can write an object to a file. So I'll probably try to start on that today and tomorrow. But those are the last two things to talk about, and then we're ready for the midterm. So I know next week's spring break. I don't know, like the week after that. Is that too soon? Kind of sucks because that means you have to spend your whole spring break studying, right? Like maybe we'll just do it maybe we'll do it the 25th. But we're going to cover the week before, we're going to start chapter 9 though. Like after spring break, we're going to start chapter 9. So we're going to be learning stuff that's not going to be on your midterm. So that's the only like drawback of that. Okay, I do give out a test review. So maybe we'll spend like one day not one day, maybe like a few minutes just going over it. But yeah, so we'll just say the 25th is when the midterm's going to be. Everybody okay with that? All right, so let's talk about what's left in this course. Is chapter 9, which is like the big one, that's inheritance. Chapter 10 also covers like polymorphism, and then it gets into sorting and all that, which is also important because that's what you're going to need in data structures. Chapter 11, I'm going to make you do on your own. That's just handling exceptions. And then chapter 12, dang, I already forgot what chapter 12 is. I think it's like recursion. Okay, what is chapter 13? The linked list and all that stuff. Okay, so chapter 9 is the important one, right? Like that's inheritance. Part of chapter 10 also talks about polymorphism and then gets into sorting. So all the sorting stuff and the recursion and the linked list and all that, like that's all data structure stuff, but like you need to know that because the next class is supposed to be like really difficult, right? The data structures class, like that's what everybody's telling me. It's kind of complicated. So I want to make sure you guys understand all that as well. Normally, like in my previous Java 2 classes, I didn't actually cover linked list and stuff like that. Like I stopped at chapter 12, but I want to go ahead and try to cover chapter 13 as well. I don't know if I should probably test you on it just so that I can motivate you to learn it. That way you're not underprepared for the data structures class. So, but anyways, that's what's left. Okay, there really isn't a lot. I mean, it's a lot of stuff to know, but I mean, we're pretty much after chapter 9. Like, there really isn't a lot to cover as far as like the topics. Chapter 11 is, I mean, that's the one we handle exceptions and all that. I'm gonna have you do that on your own, like read it and do the homework on your own, and yeah, 9 and 10 we should be done with 9 and 10 by the end or by the beginning of April, maybe like mid-April, and then we have till mid-May, and then I can cover 12, which is kind of a short chapter, and then like 13, like spend some time on 13, like learning about linked lists and all that to like, get you prepared for data structures. All right, any questions? So the final will focus primarily on inheritance and polymorphism because that's what Java 2 is about. But I will throw in some stuff in there like data structure type stuff like sorting and stuff like that. Also handling exceptions, which is something you're going to read on your own. The recursion and linked list stuff, I kind of feel like I don't want to test you on it, but I'll probably just give you homework on it so that you actually do it and not test you on it. Because that's something you're going to like, and by the time you're done with data structures, you're going to understand recursion, you're going to understand linked list. I kind of feel like that's not really what Java 2 is about, right? But I do want to make sure you're prepared for Java 2 because I'm hearing stuff from my other students that the data structures class is difficult. All right, any questions? Okay, so I'm going to go ahead and continue with the arrays. So if I remember correctly, I went over a variable linked parameter list. I didn't actually read the slides. That's where you can actually tell Java you want like a list of items to come in, and you just do it with one method. So let's see, where was that? All right, right here. Okay, so variable length parameter list. Okay, so suppose we want to create a method that process a different amount of data from one invocation to the next. For example, let's define a method called average that returns the average of a set of integer parameters. One call to average might be average, and then you take in 3 numbers. Another call would be average, you take in 7 numbers. We could define and overload versions of the average method. The downside is that we need separate versions of the method for each additional parameter. We could define the method to accept an array of integers. The downside is we'd have to create the array and store the integers prior to calling the method each time. But that's the downside of taking in an array into the method, is that when you do decide to pass the data into that method, you're going to have to make that array. Instead, Java provides a convenient way to create a variable length parameter list. Using special syntax in the formal parameter list, we can define a method to accept any number of parameters of the same type. For each call, the parameters are automatically put into an array for easy processing in the method. So the 3 dots indicates a variable length parameter list. So here they're defining the method, and they're specifying the data type. They're putting the 3 dots, and they're putting in like a name that is going to contain all those values, right? It's going to put all those values into an array. And then inside of the method is where they're actually processing that data. So if you look back at the invocation, which is here, they passed in 42, 69, and 37. So now there's an array of integers coming in inside of the list that has 42, 69, and 67. Okay. They're checking the length to make sure the length is not 0. And once they find the length is not 0, they're making a sum, setting it equal to 0. They're using the for each loop to iterate over that array, and they're storing the numbers into sum, right? They're like getting what we call a running sum. And then once they're done getting the running sum, they cast that sum to a double, and they divide it by the length inside of the length of the array. And that's how they get an average. The reason why they had to make sure that it's not 0 is that you can actually call this method and pass in nothing. So there is that risk that somebody will call average and not pass anything to it. Okay. And in that case, anything divided by 0 is undefined.
So this lowercase list is in fact a object list.
No, it would be an integer. It will be an array of integers.
But you cannot memory allocate dynamically.
So Java, it's a special syntax where Java will actually put it into memory, make like a local, like what we call a local variable inside of average, and it will put that into memory. Right, so like it will see whatever numbers you have. It's going to take those numbers and it will put it into memory just to execute this average. Once it's done with the average, in Java, once you lose a reference to that object in memory, the garbage collector will go and free up that memory. Right, whereas in C++, if you allocate memory, you have to deallocate that. Yeah. So, but in Java, we don't worry about that, right? Like once you lose that reference, a garbage collector will go and inspect the memory for what we've created and release that memory.
So why the other arrays you cannot do the same thing?
Oh.
You have to, when you initiate the array, you have to say the number of elements you have.
Oh.
Would that be the same as what you just said?
Right. Well, I mean, it's
The heap and
so every programming language has their own like syntax, right? So Java tries to make everything as easy as possible. So there are instances where you have to define the number of items you have, but then you also have the initializer list where you can just pass in as many as you want. Java will parse that list and automatically say, okay, there's 5 items in here. Great. So this is almost like passing an initializer list to that method, and Java is going to create that array for you. Yeah, I know like other programming languages, they're really strict about allocating and deallocating.
See, if you
Yeah.
read over, you get whatever is in memory.
Yeah,
You have 10 items and you read 11, it'll give you 11.
yeah, you'll get garbage. Yeah, in Java you'll get you'll have to throw an exception. Yeah. All right. So it was created. Actually, Java was created because it was trying to alleviate a lot of the problems developers were running into with C. Right. So there is a lot of overhead, which makes it an undesirable programming language for things that need to be quick and fast, like performance type programs. But it's a desirable programming language for simple programs that you rather not have, like bugs where somebody forgets to deallocate memory they use, and then you have a memory leak, something like that.
Forgiving.
Yeah. So it's a more forgiving language. All right. And then they give you another example of variable length parameter list where they're passing in an object, right? So this is going to be an array of objects, grade. Actually, what is grade? Wasn't it enumeration? Or at some point, I don't know where, but the book created an enumeration of grade. So I believe this is just like an enumerated type. I can't remember, but enumerated type or a object, same thing. It's just making an array of that, and it's printing out the value. All right. So write a method called distance that accepts a variable length number of integers which each represent the distance of one leg of a trip and returns the total distance of the trip. All right, that's pretty much the same thing as the average, except you're not going to divide it by the number of items in the list. You're just kind of summing it up, the distance for each point in the trip. So this is what they did, right? They did the exact same thing, but they just didn't divide. I don't know why they didn't use plus equals. Interesting. Maybe they wanted to make it look different than what they did over here, right? Where they did sum plus equals num. They decided not to do the plus equals. I have no idea why, but I would have done the plus equals. They just didn't divide by the number of items because they're not finding the average. You're finding like the total distance of every point that you stopped at in the trip. A method that accepts a variable number of parameters can also accept other parameters. The following method accepts an int, a string object, and a variable number of doubles into an array called nums. Okay, so whenever you have a variable length parameter list, it always has to go at the end. It can't be the first one. So here they're passing in an integer, a string, and then the variable length parameter list.
More than one variable length?
No, you can't. You can have one. You know what? Actually, I'm not sure anymore. The last time I checked, you couldn't. I know like the last update of Java, I don't really know a lot about, which came with Java FX and all that, and Lambda expressions and stuff. So I'm assuming you can't, but I could be wrong. I'll Google it really quick and I'll find out. Okay, so where was I? Okay, right here. Variable length of parameters must come last in the formal arguments. A method cannot accept two sets of varying parameters. Okay, so this book does know about the latest Java, right? So they're saying that it does not, so it doesn't. Constructors can also be set up to accept a variable length parameter list. Okay, so you can write a constructor to accept a variable length parameter list, and they give you an example of how to do it. Okay, you can read through that if you want, but I think I've already done one example. I think that's good. All right, two-dimensional arrays. This is where arrays get kind of fun. Okay, so arrays can have multiple dimensions. So before I start, I should probably draw something up about that. Oh, dang. Well, that was from my last class. All right. Okay, so the way that we are creating arrays right now currently are single dimension, meaning they're just some container and they'll have like some defined length, right? Okay, so this has 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so like we'll just say this was an int array, okay, and we'll just say like it was nums, and we said it was going to hold 9 items, right? So you have 0, 1, 2, 3, 4, 5, 6, 7, 8. All right, perfect. Okay, so you can add another dimension to this array, okay? And the way you would do that would be, the declaration of this would be int square brackets, and we'll just call this one nums, I guess. I don't know, I can't think of a different one. And then we'll say like new int, and then you have square bracket, and you can have different sizes for each dimension. Okay, so this first one we'll just say we did 9. This next one we did 3. All right, so this is the way this would look. Okay, your first one would be 1, 2, 3, 4, 8, 1. All right, so you have 0, 1, 2, 3, 4, 5, 6, 7, and 8. But then you have this third dimension, or excuse me, not third dimension, just second dimension, meaning you're also going to go this way 0, 1, 2. All right, so we have values stored inside of this array. Let's say you started putting values inside of this array, and we have a value like right here, like well, say you have more room right here. I'll put like a -1. You have a -1 there, and you want to dereference that value from your multi-dimensional array. The way you're going to do that is you're going to get the value of the first dimension and then the second dimension, the index of. So if you wanted to know what that value contained, you'll say like nums, and then there would be your first dimension and then your second. Okay, so this -1 is at index 1 and at index 2, right? So you'd come over here and put a 1 and a 2 there. Okay, now I always get confused whenever I go like more than 2 dimensions. You can actually add a third, a fourth, a fifth, a sixth. It can get like super complicated. But what Java's going to do is look for index 1. Okay, index 1's here, and it's going to look. Then you're going to look for at index 2, which is the last index of the second dimension, and you'll grab that -1. So there's a -1 at this location right there. Okay, now the way that I like to think about it, like this is like I was having a hard time understanding this a long time ago, and the best way that I can think about this is think about a 2-dimensional array as an array of arrays. Does that make sense?
Yeah.
So, yeah, so you say like int, right? You have your 2 dimensions. We'll say like nums, and then you'll say this is equal to new, and just to say your dimension. We'll make it smaller. We'll say it's a 5 by 5. Okay, so we have 1, 2, 3, 4. Right, so 0, 1, 2, 3, 4. All right. So inside this array, you have an array of 5 dimensions as well, right? Okay, so 0, 1, 2, 3, 4. Inside of this location in the array, you have an array of 5 dimensions. This one. Well, it looks, I know it's easier to look at the other way, but the way that I think about it is you have an array that can hold 4 arrays that are a size that can hold 5 items, right? So like there's an array inside of this location, right? And if you want to add a 3rd dimension, right, then you can say like come over here, put 5 there, right? This is where it gets kind of funky because it'd be really difficult to draw, but then here you have another 5. Here you'll have another 5. Like each one of these spots you'll have like another 5.
So you have a slice.
Yeah.
Slice of the cake.
Yeah. So like that's where you come into like making something cubed, right? Oh dang, I messed that first one up.
And the fourth dimension is just yet another cube.
Yeah, so,
That's the secret.
and now I know it seems like, oh, when will we ever use this? But like I actually took a graphics class at UTSA, and they used arrays of the fourth dimension, right? So the first two would be the XYZ coordinates in space, and the next one would be some other attribute that they wanted to give to that point. Like whether it be like how fast it was traveling, right? Or, yeah. You can use, actually, you can use four-dimensional arrays for color, right? Your red, your green, your blue, and your alpha, like the transparency. I see that being done a lot. Yeah, it can get super complicated. I'm not gonna like really test you guys on anything like this, but I am gonna give you the example of the tic-tac-toe game, right? So tic-tac-toe game is super easy, right? It's basically a two-dimensional array where both arrays are have the size 3, right? So you have 0, 1, 2, 0, 1, 2. Now the thing that gets confusing whenever you're managing this, right? Whenever you're trying to figure out like, okay, they want to put a X at one of these spots, you know, they gave you, you know, row and column numbers. So they give you like 1 and 2, right? So you come here, you go to 1, and then you go down to 2, and you're going to put O there. But you have to be consistent of what you consider your row and your column, because Java doesn't care, right? If just say you want, you know, if you're going to do 1 and 2, you decided that the first dimension is going to be this top line, the second dimension is going to be going this way, then this is the correct spot. But if you reverse that logic just by mistake because you're, I don't know, just say you're getting mixed up, you know, 1 can be here and the 2 can be there, right? So you have to be consistent of where you're actually putting these index values. And it doesn't make sense now, like when I'm explaining it, but like as we're actually coding it out, I believe it will make sense.
It has to, one of the coordinates has to be, either row or column.
Right, exactly.
What
So
you're saying is true only in a 2 by 2 or a square array. If the number of columns and rows are different.
I mean, you could still,
If they're different, you cannot make that mistake, is what I'm saying.
well, you can make the mistake if you go outside of the range of one of them, right? But you can still make the mistake. It wouldn't matter like if this looked like this, right? And you say, okay, put something at 0, 1, right? So you say, okay, here's my 0, here's my 1. Okay, I'll put something there. Or like if you wanted 1, 0, then 1 here. Well, I guess it's the same thing. Bam, no, wait. 1, 0 would be 1. I said this was 0. This is 1. Now I'm saying 1, 0. So 1, 0. But you really wanted it in 1. Oh, you really wanted it here, but you put it in there. You can make that mistake if you're still within the range of that array. So whenever you're managing a multidimensional array, you have to be consistent. You have to say, okay, my X values are going to go here, my Y values are going to go here, my Z values are going to go here, right? Like if you ever decide like, okay, well, you know, you have an X value, but you specified it right there, then you're going to kind of mess up where that data is being placed or retrieved within that multidimensional array. Okay, I mean, yeah, and when we do an example, it might make a little more sense. All right, I'm gonna hop back to the lecture. I'm just gonna read the slides and then do an example of tic-tac-toe. Okay, so two-dimensional arrays. One-dimensional array stores a list of elements. So here's a one-dimensional array. Two-dimensional array can be thought of as a table of elements with rows and columns. So they're giving you like a diagram of a two-dimensional array. To be precise, in Java, a two-dimensional array is an array of arrays. A two-dimensional array is declared by specifying the size of each dimension separately. So in this two-dimensional array, they're saying 12 and 50. An array, what the heck? That's confusing. An array element is referenced using 2 index values. So if you want to reference a particular value within a multidimensional array, you're going to use 2 index values, right? These values have to fall within the range of what you specified. So if you, or the second dimension, you can't put a 50 because the second dimension goes from 0 to 49. You put a 50 right here, then you're going to be out of bounds. The array stored in one row can be specified using one index. Okay, 2-dimensional arrays. Okay, so here they're giving you an example, a 2D array of integers or array of integer arrays. Okay, so express the table, 2-dimensional array, a 2D array of integers, or an array of integer arrays. I guess they're giving you different ways to think about it. I don't know. All right, and then next one is table 5. Okay, 1-dimensional array is array of integers. And then here they're saying when you dereference this, you're getting the actual integer. All right. So here's the expression. If you have a 2-dimensional array, is your 2D array of integers or your array of integer arrays, however you want to think about it. This next one, they're putting the actual first dimension in here. That first dimension is going to give you an int array, right? An array of integers. If you put both dimensions, you're actually going to get back the int. Right? So you need both dimensions to get that integer back out. They give you an example. I'll do my own. And okay, that was it. All right, let me do a tic-tac-toe game, which should be pretty simple. I'll use IntelliJ. Should have opened this up sooner. All right, I'll just use Notepad++ because it shouldn't be that difficult. All right, let's see, what do I have? This is all the Java 1 stuff. Okay, under simple demos, and I have a huge mess in here. Okay, I'm going to make a new demo called tic-tac-toe. I'm going to make a new folder called tic-tac-toe. So I'm going to rename this. Rename. All right, and I'll call this one tic-tac-toe board. All right, so I'm going to make a class just for the actual, oops, let me do that. Make a class just for the actual board of the tic-tac-toe game. So it's not going to be the actual game where we're asking the user what spot you want to place an X in, but it's just going to be the actual board, which is going to be a class that simply maintains a 2-dimensional array of size 3 for the row and columns, or columns and rows, depending on how I organize this. I'll say public class tic-tac-toe board, and then I'll say private int. Actually, no, I don't want to do an int. So the data type would be the data type that we're actually going to place inside of each location. So this is where it gets kind of confusing because we'd have to, we could do a character, but then you need a character to indicate it's empty, right? Like what character we're going to put to indicate it's empty? A blank space, I guess? Okay.
Well, you have to compare only with 2 characters. Everything else is blank.
Yeah, okay, so we'll do chars, okay? So we'll say private char, and we'll do 2-dimensional there. And that means we're going to have to initialize this to be all spaces initially, okay? And we'll say this is our board. All right. Okay, so then in our constructor, we'll say tic-tac-toe board. And this is, we're going to initialize the board to be empty. But maybe you want to, actually, we probably want a method. We probably just want to call a method called like empty board, right? A reset board. How about reset board? Right, and the reset board was just, because as you're playing the game, like if somebody wins, you're going to want to reset the board. Might as well just make a method you can call every time you want to reset the board. All right, so right here, I'll have a method called public void reset board. All right, and what the board is going to get reset to, so there's several ways you can do this. I think you can do initializer list of, or you can do initializer list of initializer list. Does that make sense? So let me do the way that most people think it needs to be done. Is we'll say like for, and actually, hold on, I'm gonna make this, I'm gonna do this right. I'm gonna come up here, I'm gonna say public static int num of spaces, I guess. Dang, I don't know what I'm doing now. 3. Oh, I don't know. I'm gonna leave off the constant for now. Okay, so I'm gonna come over here. I'm gonna say int column. Are we gonna? No, actually row. We're gonna go through the rows first. We'll say int row is equal to 0, while row is less than board dot length, right? Because that'll be your first length of your dimension, I believe. Oh no, I'm so confused. Right there, 0. You have to put 0. That'll be the length of the array at that index, and then we'll go row plus plus. Is that right? That doesn't seem right to me. I'll have to actually run this to find out. I'm gonna leave that off for now. All right, so then what I'm gonna do, we'll make it super easy because I don't wanna like mess this up and confuse everybody because I'm already confusing myself, is I'll just put 3 there. All right, so then inside of here, we'll say int column is equal to 0, while column is less than 3, column plus plus. All right, and then what we're gonna do is just say, okay, well, the board at that location, that row and column is gonna be equal to space, right? That'll be the way that we reset it. Okay, so now what I'm gonna do is I'm going to make sure this actually works. Now, I do need to actually, I didn't actually instantiate my board, my 2-dimensional array, so I'm gonna come up here and say new char and give it a 3 and a 3. Okay, I wanted to like make 3 a constant, but I didn't know what to name it because I'm using it here and I'm using it there and I'm using it there. I'm using it everywhere, right? To say if I wanted to increase the number of spots on this board for some reason, even though tic-tac-toe normally stays a 3x3, I can just change that value, right? I can, the more I think about it, the more I feel like I should put a constant. Okay, so I'm gonna say public int, and I'll call this one, or actually I'll make it static. Public static final int.
What's the static for?
Static makes it so that if you don't have an instance of tic-tac-toe board, you can still reference that value, right? Because it's gonna be the same for all instances of tic-tac-toe board. So you don't need to like make your own variable for every instance of tic-tac-toe board, right? So this board here, because it's not static, every object that you instantiate from tic-tac-toe board is gonna have its own 2-dimensional array. If I didn't make this static, then every, just say if I made it final, right, but not static, then every instance of tic-tac-toe board is gonna have their own integer, which seems like a waste of space, right? Because I'm making it constant, so it's gonna be the same value for everything. Does that make sense?
Yeah, yeah. So it's more of a memory.
Memory and I guess easier maintenance maybe. Yeah, I mean it does save on memory. I mean integer is pretty small though, but yeah. So this variable is declared for the class and not for every instance of the class, right? I'll just name it max. I didn't know what to name it. That's why I didn't want to. I was just so confused on what to name it. 3 name. All right, so I instantiate the board and then I just fill it all with chars. I want to see what I'm doing, right? So let me make like a display board method. Okay, so we come over here, say public string display board. Okay, and this is where we're gonna get kind of, actually, I don't have to use a for loop. It'll be interesting to use a for loop, but I guess if I really didn't want to, I didn't have to. I could just do something like return and then string dot format, and then this is where it's gonna get a little funky. So I want to have like lines up top. I don't know how I'm gonna format this yet. Okay, and then maybe like that, right? Okay, and then there's gonna be like a percent, I guess C for char. I'm not sure. I have to look at the. Man, I feel like I'm just being like really wasteful with this. I should make like a for loop, print out each character, but I think that would just, I don't know. I'll just do it this way for now. All right, so let me copy what I did here 3 times, and then the last thing would be, that's kind of like what I want to print out, right? So it looks more like an actual tic-tac-toe board. I guess maybe, I don't know if I should have like lines in between these, but it might make it look too tall. Okay. Oh yeah, you're right. I need the new line after each one. So new line, okay, and then new line. All right. So then I'm going to inject those chars from my board. So really, it's just like 0, 0. I have to do this 9 times, which is going to be kind of annoying. Which is why I thought like, oh, I can probably just, yeah, do a for loop. No, I don't think you can. I've never tried. That'd be cool if you could. All right, so I'm just basically just injecting whatever values I have inside of wherever the C is at. All right, so I have a 0, 0, 0, 1, 0, 2. Dang, if I would have just copied this instead of the 0, 0, I could have saved myself some time. All right, so this would be like 1, 0, 2, 0. This would be 1, 2, 1. Just to be 1, 2, and 2, 2. And I'll get rid of that. All right, let's see if this thing actually works. So I'm gonna come over here and make a new one. I'll save this as tic-tac-toe game. All right, so public class. All right, and then I'll say tic-tac-toe board. And I'll say T-board, I guess. I don't know. It's going to equal to new tic-tac-toe board. Okay. And then I'm just going to do a system.out.println T-board dot, I forgot what I named my method.
Display.
Oh, display board. Okay. All right, and I'm going to compile and run. Hopefully it compiles. Yes, it compiled. It's awesome. I was worried that it wouldn't. All right, so then to run, dang, I'm off on the lines, right? The top and bottom lines. But yeah, I mean, you can see where I'm going with this, right? So let me just add a few here. Dang, that's too many. There's 3 too many, right? If I'm looking at this one. Yeah, so delete 3. All right, that looks better. Okay, so you instantiate the tic-tac-toe board. You basically just create it and we reset it by adding the spaces. Now you could do it like this, the way we did here. The other way that you can do it is using an initializer list. But if you use the initializer list, you don't have to declare it up here. It just means every time you reset it, you're going to do your declaration. Dang it, what the heck? Why am I holding shift? All right, so every time you reset it, you'll just assign the board to a new list of blanks. And you're going to lose that reference, which I don't know if that's like causes a lot of overhead. Sure it does. All right, so you get to say like board is equal to my initializer list, and then you need three things, right? Because you're doing your row, right? So you're gonna need something here, which would put another initializer list, here another initializer list, and here another initializer list, and it's also 3 dimensions. So we put like, we have a chart right there, chart right there, chart right there. Okay, I'm gonna go ahead and just copy what I have in here. All right, and this should work. If it doesn't work, apologize for wasting your time showing this to you. All right. No,
Yeah, there's a semicolon.
no, it's getting met or not a statement. Okay, is it the semicolon?
Probably. Not like semicolon.
All right. Come on, please work. Oh.
I think you need semicolons between instead of commas
I don't think so.
No, I think this is.
All right, compile. And it's still mad at me. Okay, so, I think this is where it gets kind of like confusing. I think this is, if you're going to do that new,
That's outside.
okay, we'll do new. I have to read about Java because I always forget like how this thing works. How did I do that? Remember when I did the die initializer list? Didn't it just work? I thought it was gonna be different. Oh my god, I'm making a mess. Oh, all right. So instead of like wasting your time, I'm gonna come over here. I'm just gonna Google it, and I'm gonna say Java multi-dimensional, or how about just two-dimensional initializer list. Initializer. Okay, there you go. And I'll just click on this first example. What the heck? That's exactly what I did. That's what I thought it was going to be. I don't know. Did I mess something up? I'm going to look at this really quick. Control Z. I have a list of, right, because it's, so I'm starting my multi-dimensional array like that. I'm saying I have 3 items. And but for some reason that didn't compile. Let me see if I notice anything weird. Don't notice anything weird. All right, I don't know what the problem is. Try to compile it one more time just to see if it likes it, but I'm pretty sure I already had that before. All right, so this could work. I know it works because I'm pretty sure I've done it before. So, All right, let me just look at Google one more time. Maybe, yeah, I don't know. All right, well, I'm gonna have to like go,
Oh,
wait,
you have to have brackets in front of,
I don't think I need that, but I hear they're doing that, but I don't think it's, because I already declared multidimensional up top, like inside of my class. Maybe you can't do it for chars for some reason. I don't know why that would be a problem though.
On that one, it shows there's a comma at the end of the third one. I don't know what's that.
Syntax error. Sure, I don't know. Okay, I'll put a comma right here. Hopefully that's the problem. Cross your fingers. No. I didn't think that would work. All right, so it doesn't like this space thing. Let me just put like, maybe I need an actual character. I don't know. All right, well, I'll figure it out later and I'll update you guys.
well,
Unless somebody figures it out before me.
looking at the private char, initialization, and it's exactly what you're doing, but, it says private,
It can be done. I know it can, but I did something wrong. But anyways, once I figure it out, I'll update you guys and I'll let you know. But let's continue with this because I don't want to waste a bunch of time trying to figure that out. Okay, so that's resetting the board. Is just putting spaces at every location. Now we got to think about, okay, well now if the user, like this is where the interface comes into play, right? So do you want to have, well, I guess I have an idea. Maybe if we put like a one, I don't know. So this is what our board looks like. Okay. Now, how do you want the user to specify what spot he wants to put it? I can tell him like this is spot 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right? Like how are you gonna display that to him? Right? We could probably make another. Like this, we have to think about like, you know, what your board is actually gonna do, and what part of it is your driver is gonna do. Okay, so I feel like the board should be as dumb as possible, right? So I'm not going to take any value like 1 and then know that's 0, 0, or 2 and then know that's 0, 1, 3, know that's 0, 2, and then 4 would say is 1, 0, right? I want them to give me the row and the column number, right? 0 through 2, okay? So I'm going to make my board as dumb as possible. I'm going to say public int, or actually, what am I saying? Int. Public void set spot. Okay, and the way we're going to set the spot is we're going to need an int for the row, an int for the column, and then a char for the character that they want to set. Okay, and I messed it up. I can't name it char. I'll name it char C. Okay, actually I could name it char. I think Notepad++ was just confused. Pretty sure, well, maybe not. Okay. All right, so the way I'm going to do this is simple, right? I guess you will have to check to see if you're out of range, right? So you're going to say if row is greater than or equal to 0 and row is less than or equal to our max. And the same thing for column. Copy what I did there, paste it, and then change this to column. All right.
Wait, wouldn't max be wrong because then it would take in a 3 instead of
Oh, yeah, you're right. Good catch. It needs to be less than, not equal to. Okay, because yeah, max is 3. Our minimum value is going to be, we want it to be 2. All right, good catch. All right, so once I know that my data is correct, then I can just take whatever chart that was passed in and just say board at that row and that column. So the first one's always going to be row for us. The next one is always going to be column. And we're going to set it equal to C. All right, so like that's
Only if it's not taken.
right. We'll build in that logic, right? Or you guys are going to build in that logic, I mean. But you're right. You're going to have to check to see if that spot's taken by. If that spot's not space, then you're going to set that spot. Okay. And like, and now that you bring this up, like a good thing here would be, like, return a boolean. All right. Because if you're relying on the user to give you data, then perhaps the only time if you return true, that means you successfully set, right? If you return false, that means like you're not able to take that spot, right? And we can put more logic in here, like check to see if there's no space before you actually set it. All right, let's go back to this tic-tac-toe game. Okay, let's make it like a real game. So now we have to take user input. How much time do we have? All right, we have a little bit of time. Let me see how much I can get done. We say import java.util called scanner. We'll come up here and declare our scanner object. All right, and then they want to quit the game, I guess we'll just say, we'll make a boolean right here called end game. We'll set it equal to false. All right, to display the board, just, I don't know, just to display it, we'll say do while you're not ending the game, but you don't want to end the game. And then we'll say system.out.println enter the row to place your character or char or X, I don't know. Okay, we'll say the user's X all the time. Okay, he's gonna enter in a row, we're going to take that in, and then we're going to ask them to enter in a column. Or maybe we ask them for both, enter in row, column. Okay, what we'll do is ask them one thing at a time. So that means we're also going to need an int for row and an int for column. So say row is equal to scan.extent, and then column would be equal to the same thing. All right, so once I enter in the row and column, then I'm going to call my board. Oops, that's not it. What did I name it? Keyboard, and I'll do set spot is what I named it. Okay, and I'll pass in the row. I'll pass in the, actually, since I'm making it return a Boolean value, I can do this. I can say if not, that can give them like some error message, like unable to set spot or something like that. So pass in the row, we'll pass in the column, and then we'll pass in X. And we'll say system.out.println, say could not set X at spot. And we'll have the row and the column. All right, let's see how that looks. All right, so right now I'm only setting X's. Yeah. Oh, and I never actually end the game either. So we're probably going to have to ask him, like, enter something to end the game. Okay, so let me clear the screen. Oh, you know what? I don't even print either. So I need to print after. Okay, so else The else would be if they successfully set, and then that's when I'll print out the board again. All right, so compile. Dang it, didn't compile. Oh, I'm missing one parenthesis. Right, I have the parenthesis for the method, but I don't have it for the if condition. All right, so enter the row. Okay, I'm gonna enter in like 90 and 100. Could not set X at spot 90 and 100. You know, I need some new line, some separation. I don't like the way that looks. So I'm gonna come over here and put a new line every time we come into this loop. Okay, so let me Control C to stop the program, compile, and run. All right, so we know that we're able to like make it fail and not set anything. Okay, so if I enter in a good spot like 1, 1, 1, 1, right, I put the X at 1. Now if I enter in 0, 1, cool, and then like 0, 2. Yep, there you go, tic-tac-toe. Is that the way you play? No, I'm not sure. I'm just kidding. No, I know. But so I'm just specifying like where I actually want to place this, and perhaps I don't know. Maybe like you're taking turns on the console, so depending on whose turn it is, you know, like maybe you just set like some flag called like Boolean is I don't know how to spell X. Is, how about this? How about turn is X, and we'll set that to true. Okay. And the other thing I didn't really like was this print line where, yeah, I didn't like that. Get rid of that. Okay, so then right here where I'm actually setting the X, right, I'll just say this. Okay, and actually I should probably count the number of turns. That's probably like, that way you can see how many turns it took to win. So instead of using a Boolean, I'm just gonna use an int and call like num of turns. Okay, so actually we're gonna start off with 1 turn, right? So number of turns. So if number of turns divided by 2 does not equal 0, then you're going to put an X does not equal 0. Then you put an X, else you're going to put an O. Does that look right? It looks kind of
Well,
funky,
it
but
wouldn't work. You just had to, every time that you run, you just negate the boolean. It's the same as you're doing.
well, I thought like it'd be better to keep track of the number of turns. You know, like when somebody wins the game, they won in this many turns.
What does the
Right.
percent sign do inside of that?
Oh, it's you're dividing it by 2, right? It gives you the remainder. I'm taking the number of turns, dividing it by 2. Percent will give you the remainder. So if it's not 0, that means you're the first turn. And like it's like every odd turn would be X, right? Because I initialized number of turns to 1. But actually, this is gonna be wrong though, right? Because you're gonna increment every time you go through the loop successfully. So I should start off at 0, and then check to see if this equals to 0. Oh, dang, what happened? All right. Okay, so now when I play, let me Control C, clear, compile, run. All right, there's my tic-tac-toe board. So if I want to put one at 0 and a 0, all right, and the next turn is going to be O. I should have changed the X, dang it. Oh well, we can do more stuff like that later. I'm talking about in the prompt. Okay, so then the next one, we'll just say like 1 and 1. All right, so we'll put the O in, right? Now it's X's turn again, so we'll just say like 0 and 1. Okay, now O is gonna try to block him. It'll be like 0 and 2. Now X is gonna go, but he's gonna make a mistake and say like 0 and 3. All right, told him it couldn't set it. It's supposed to be X's turn still, right? So the next character that gets put in here should be an X. So then I'll say 2 and 2. Yeah. Right, so I mean the logic is working, except it's always telling me enter in an X. Okay. All right, so I'm going to give you, so the homework assignment for chapter 8, I'll write up all the details. I'm going to give you a skeleton of the tic-tac-toe game, and you're basically going to add in the logic, except you're going to put an AI, like not a turn-based type thing where the user is playing the computer, so you're randomly just going to, the computer can be like super dumb, unless you want to like go all out into this thing and make the computer smart by like checking to see where the user put the X's and trying to figure out where's the best place. But the computer should just randomly choose, 2 spots. If it's taken, then choose again. Taken, choose again, right? You could get caught in an infinite loop if you don't do your logic right, right? But I mean, the computer is going to be like really dumb where it's just randomly choosing whatever's left over. So, okay, that's going to be the homework assignment for chapter 8. I'll put it up probably tomorrow when I'm at work. All right, any questions on that? All right, so the next thing to talk about before the midterm is going to be using the serializable class, and I'll go ahead and do that on Wednesday. Okay.
Wait, did you say serializable?
Serializable class, or I said class. I'm sorry. Serializable interface. Serializable. Yeah. So it's basically.
In series?
So it's just like it's an interface. So you'd say implements, and it's believe it's I don't know. I don't even know how to spell serializable. Serialize. Oh, there you go. And once you do that, Java knows that it can take your object and serialize it to where it can store it as text data. But you won't be able to read it because it does like some funky stuff to it. But then you can deserialize it by reading that file and reading it back to an object. It's actually pretty cool. This is actually used a lot because a lot of objects are serialized and deserialized.
So this is for binary, right?
This is for what?
This is for binary, right? So you're just defining binary structure based on, binary file based on object structure.
Right, yeah, so that you can actually write out the object to be stored.
As long as you have the definition of the object.
Right. But if you don't have it serializable, then you won't be able to write it to a file.
Right.
Yeah. So I'll show you some new classes that we can use to do this. And yeah, then we'll be ready for the midterm.
How does that work with object array?
Oh, it's just a way of, so if you mark a class serializable, that just means that you'll be able to store it long term after the program shut down. Program starts back up, you can read in that data and remember like what state your object was in, right?
But it'll still be different kinds of objects.
No, you could do this on any type of object. You can add serializable to the student class, to the die class, like whatever. Yeah. So, all right. See you guys on Wednesday. And I'll look into the initializer list thing that I messed up.